Hey, in this video, we're going to discuss the function 1 over x again, but this time we're going to take the limit as x approaches 0. Why is this point, or this x value, important on this graph? Well, if you recall, we've already drawn out this graph for you one time, so let me draw it again. So 1 over x, roughly speaking, is a curve in the first quadrant and a curve in the third quadrant. So, very rough drawing, but you get the idea. So this is 1 over x. If you recall, we've already talked about approaching the horizontal asymptote as x goes to plus or minus infinity. What we haven't discussed is what happens as x goes towards 0. Where on this curve would x be approaching 0? Well, x equals 0 is the vertical y-axis here. This is actually a vertical asymptote. So as x approaches 0, we're approaching a vertical asymptote. Notice here we are approaching 0 from the right in one of these questions and from the left in the other question. Why are we having to do that? Because in general, there is no common limit. If you approach your vertical asymptote from the right, so here's x marks the spot, follow your curve, what is our function value approaching? Our function is going up and up and up. It keeps getting closer to the vertical asymptote, but every time it gets closer to the vertical asymptote, it's also getting taller, meaning the y value is increasing, the function value is increasing. So we are approaching positive infinity as we approach the vertical asymptote from the right. On the left-hand side, or from the left, if we approach our vertical asymptote, our function is going down. So the closer we get to our vertical asymptote from the left side, the further down our function goes, which means our function values are going more and more negative with larger and larger negative values. So we're approaching negative infinity. So in general, there is no limit because the limit from the right is positive infinity, the limit from the left is negative infinity. Now, you're going to be dealing with functions that have x in the denominator, a finite value in the numerator, where the denominator is approaching 0. Now, it's not always going to say x approaches 0. It's going to be saying x approaches 3. But as x approaches 3, the denominator goes to 0. You're going to have some interesting things like that. So what we need to do is come up with a better way for us to figure out what happens as we approach a vertical asymptote. So one thing I want to encourage you to do is recognize that you're approaching a vertical asymptote. If we can figure out that we're approaching a vertical asymptote, then we know that we either have to go up to infinity or down to infinity, negative infinity. The question is which one? So if we know we're approaching a vertical asymptote, number 2, we know that the limit is plus or minus infinity. Step number 3 is to figure out which one. So let me show you a little trick to help you figure out which one you're approaching. If you don't have the graph to help you, how are you going to figure this out with algebra? So notice, we're approaching x, or letting x approach 0 from the right. So if you think of a number line, here's 0. What number's to the right of 0? Don't go too far away. Go as close as you can. So you could go to 1, but technically that's a pretty big gap. Go as close to 0 as you're willing to go. So maybe 0.0001. If you plug that value into your function, you're going to get a really big positive number. You're going to end up with, let's see, 10, 100, 1,000. You're going to end up with 10,000 as your answer. So a really big positive number. This is indicating for you that you're approaching the asymptote in the positive direction. In part B here, if we do the same concept, what number is immediately to the left of 0? You could say -1, but that's a good gap. Let's go as close to 0 as we can, but staying on the left. I wrote the -1 to help you remember that it's negative numbers to the left of 0. So if I pick a negative number, let's say -0.0001. That's really close. You can go closer if you want, just put more zeros in there. If I plug this number into 1 over x, I'm going to get a really big negative number. I'm going to get negative 10,000. Which is indicating that we are approaching a big negative number. We're approaching negative infinity. So 1 over x is the basic concept. It tells us we're approaching a vertical asymptote, and we're able to figure out which one by simply testing. That's the easiest way. There are other ways to do this, and feel free to look on Google or in our textbook. I'm going to show you some ways, but I've found that the numerical approach is what students tend to understand the best. So let me show you another example. First step, we have to be able to recognize that we're approaching a vertical asymptote. So how do we know we have a vertical asymptote? So this is a vertical asymptote because the denominator equals 0 as x approaches 1. So if you try and plug the 1 into the denominator, you get 0. Double check though that it's not a whole. Remember, a whole is when you can cancel or reduce your function. We're going to see some more examples of that in a minute. All right, so first of all, this is a vertical asymptote, so that's step number 1. So step number 2 is to remember, if you're approaching a vertical asymptote, you can never actually reach it. All you can do is get closer to it, whether it's in the positive direction or the negative direction. So our limit is either plus or minus infinity. Which one is it? Well, we're approaching 1 from the right. The little plus sign means from the right, remember. So I'm going to create a little number line to help me remember who's to the right of 1. So here's 1. So to the right of 1 is 2. So I need something in between 1 and 2. As close to 1 as I can get. So just a little bit bigger than 1 would be 1.001. If we plug that number into this function, 1 over x minus 1. So that'd be 1 over 1.001 minus 1. Which is 1 over, let's see, 1.001 minus 1. The 1's cancel, so we end up with 0.001. The important part here is that this is positive. Okay? Which means what? Which means we have the answer. So step 3, we know that our limit is approaching big positive numbers, so we are approaching positive infinity here. So that would be the limit as we approach the vertical asymptote at x equals 1 from the right. Let's do the same thing, but from the other direction. So first of all, number 1, we have a vertical asymptote at x equals 1. We can't cancel that factor out, so it's not a whole. Number 2, because we're approaching a vertical asymptote, our limit has to be plus or minus infinity. Which one? Well, let's test. So here's my 1. We need to approach it from the left. Who's to the left of 1? 0. So who is just before 1? Now, this is where you got to be careful. A lot of students put 1.001. It's not true. It's 0.999. So if I put 0.999 in to my function, what values are we approaching? So 1 over, let's see, if we subtract those, we end up with, negative 0.001. So this is going to be a negative value. What does that mean? The closer we get to 1 from the left, the more and more negative we're going to go. So what is the official limit that we're approaching if we approach 1 from the left? Negative infinity. Okay? So that's if you have one asymptote, one simple function, just so basic. We're going to make it more interesting. So here we have some examples where there's some more stuff going on. Same basic concept, but you've got to be able to recognize this. So let's just go back through our limit rules. If you're trying to take a limit, this is a nice rational function. All of our limit laws can be applied here. So what do we do first? First step when you try to take a limit, plug it in, see if it works. So if I try to plug in 3, I end up with 3 minus 3 or 0. 3 minus 3, oh, that's 0. 0 times anything, well, that's 0. This is what we call an indeterminate form. Meaning we can't determine the answer from this form. So we have to do some algebra. So the next step is some algebra. What algebra could we do to this problem? Notice on top and bottom, they both have x minus 3. If we reduce, cancel out an x minus 3 from the top and from the bottom, let's see what our new function is going to be. So we have 1x minus 3 left on top and 1x plus 3 left on the bottom. What did we cancel out here? We canceled out what was making it become 0. Because it's on top and bottom, this is a whole at x equals 3. Does a whole affect a limit? No, whole does not affect a limit. A asymptote will, but not a whole. You can still approach a whole from both sides. So now that we've done some algebra, the next step is to try and plug in again. Let's see if we can get an answer this time. So if we plug in 3, we get 3 minus 3 over 3 plus 3, which is 0 over 6. Is that an answer? It is, but you're not done. Make sure you finish. 0 divided by 6 is 0. We found the limit. So in this case, we didn't have a vertical asymptote to deal with. So I gave you an example where it looked like there might be one, but it turned out to be a hole. So watch out for those tricky ones. Let's try another one. So in part B, again, we can try and plug in 3. 3 minus 3, that's 0. 3 minus 3, that's 0. We have it again. So 0 over 0, again, indeterminate form, so we're not done. What do? If you have an indeterminate form, you should try algebra. What algebra can we apply here to try and simplify? Well, x minus 3 is on top and bottom, so we could cancel those out. What does that mean we just canceled? A whole at x equals 3. Well, let's see if what's left we can take the limit of. So we have 1 on top because we canceled everything out, we put a placeholder. Remember the x plus 3 is on the bottom. It's a common mistake. Just because you cancel everything out, this x plus 3 still has to stay on the bottom. Let's try plugging it in and see if we can get an answer. So 1 over 3 plus 3, or 1 over 6. There you go, you have your limit. Again, it looked like you were going to have a vertical asymptote, but it wasn't. So you've got to know when to recognize that you need to approach from the left and the right and talk about infinities. Let's try another one. All right. Ooh, well this is kind of interesting. Now we're just looking at the limit from the right. I wonder why. Let's try and just plug it in, see what happens. So 3 minus 2, that would be 1. Well, that's good. 3 minus 3, that's 0. 0 times anything, that's 0. Well, that's undefined. Could we do better than that? Absolutely. This is undefined because the denominator is 0. This x minus 3 right here is causing us to have a vertical asymptote at x equals 3, the number we're trying to approach. So if your denominator is 0 and you can't cancel it, then you have a vertical asymptote you're dealing with. So that's step number 1 of dealing with a vertical asymptote limit. Step number 2 is to remember, if you're approaching a vertical asymptote, what are your limit choices? You have to be approaching positive or negative infinity. Which one is it? Draw your number line. We're trying to approach 3 from the right. So who's after 3? Who's to the right of 3? 4. Pick a number really close to 3. So 3.001 maybe? Let's try and plug that into our function. X minus 2 over x minus 3 times x plus 3. And let's see what our function approaches. So 3.001 over, minus 2, over 3.001 minus 3 times 3.001 plus 3. All right, so on top, 3 minus 2, that leaves 1.001 over 3 minus 3. So that's positive 0.001 and 6.001. Remember, when you're trying to figure out the vertical asymptote, all you need is the sign. So I don't need to punch all this in my calculator. I need to look and say, hey, there's no negative numbers. That means this is a positive. So as we approach 3 from the right-hand side, we have just discovered that the limit has to be positive infinity. There's your answer. All right, let's try another one. This is our last one here. Same steps. Try and plug it in. So if we plug in 3, we end up with 3 minus 2 is 1. 3 minus 3, there's our 0. The denominator is 0, but not something we can cancel out, so we have a vertical asymptote at 3. Well, that's good because this is the same problem we just did. We better still have vertical asymptote. All right, so number 2, what is the limit? Now, don't assume that because the first one was positive, the second one is going to be negative. It's not always the case. Powers can mess that up. Always test and figure out. So the limit, because we're approaching a vertical asymptote, is either positive or negative infinity. You just have to figure out which one. So number line, here's my 3. We're approaching from the left. To the left of 3 is 2. So immediately to the left of 3 would be like 2.999. That'll work. All right, let's plug it in. So x minus 2 over x minus 3, x plus 3. We end up with 2.999 minus 2 over 2.999 minus 3 times 2.999 plus 3. Work it out. On top, you get a positive number. On the bottom, that one's a negative. Negative 0.001 and positive 5.999. All you need is the sign. You have two positives and one negative. If you multiply and divide all those together, what's your sign going to be? You're going to get a negative. So, number 3 over here. According to our testing, what is the limit going to be as x approaches 3 from the left? Negative numbers all the way to infinity. And there you go. All right, I hope that helps you. If you have questions, reach out to me. Work hard, study hard, and I'll see you in the next video.